All right, guys. So pushing through this math portfolio. We're up to number 7 now, and this one will take you a little bit. So just make sure you listen to what I say and pause it and answer these questions how I tell you to answer them. I can't give you the answers, but I'll talk you through it. So look at number 1, right? What do you notice about the graph? You'll notice that the line, there's an x and a y axis. Is it a straight line? Is this curving line straight? I don't think so, right? So the question asks you to state whether each example represents a linear function and explain your reasoning. Keywords, explain your reasoning. All right, so is this a linear function? Well, what does linear mean? When you look at a graph, the word linear means that the line is straight. So when you answer these questions, you're going to answer it like this. This example does represent a linear function. Or this example does not represent a linear function, depending on what you decide, right? So remember, to be a linear function, a graph has to have a straight line. So if we're looking at a graph that doesn't have a straight line, I would write something like this example does not represent the linear function because it's not a straight line. The line isn't straight. The graph does not have a straight line. Anything that explains how the line is not straight. So you should start your sentence like this and explain, right? Oops. Explain using the word because. And then if to be linear means it's a straight line, how could you explain this not being linear if it's not linear, right? Okay. So that's how you would answer something with a graph. Okay? So you know what I'm going to do? I'm going to go to the next one. Right here. Actually, I'm not even going to go to this one yet. I want to go to the graph since we're working with graphs. So I'm going to take what I wrote here, because that's my template, copy it, watch this, paste it, and I say, is this an example of a linear function? Well, is the line straight? If it is, remember, we would have to remove the not and say this example does represent a linear function because, now, again, when you describe how a linear function looks on a graph, there's a certain thing it has to be. I said it a few times, that line has to be straight, right? So think of a way to explain how this is or is not a linear function. Is the line straight? Then it is. If the line is not straight, then it is not. And I think that's the only graph we have. Okay. Now let's look. We have two different equations. We have y equals 3x squared, and we have y equals 2x minus 5. So you notice two things. This is something you've probably seen before and probably graphed. This is something you probably have not. So when we graph, it should be in the y equals mx plus b form. Sorry, plus b form. Meaning it should be y equals a number, x, plus or minus another number. Or the slope times x plus or minus the y-intercept. And that's called slope-intercept form. So which one of these two equations looks like this? Meaning there's a y equals, hey look, this has it, mx, ooh, a number times x, we got that here. We also got it here, right? Y equals a number times x, the slope. And then it has to be the plus, or you can be minus, another number. Ah, I got that there. So here's what I'm going to do. Since I already see that something's in slope-intercept form, I would write this example does represent a linear function because it is in slope intercept form, and if we graphed it, it would be a straight line, right? Because that's what it does look like. So let's say we had something, an equation that was not in slope-intercept form. Let's just say we didn't, right? Then we would have to write this example does not represent a linear function because, remember, we keep this wording. We would say it does not represent a linear function because, well, if this does because it is in slope-intercept form, an equation that would not because it is not in slope-intercept form. I repeat, to explain it, you need to explain that an equation is not linear because it is not in slope-intercept form. And if we graphed it, so if we took an equation not in slope-intercept form, put it on a graph, the line would not be straight. Again, the line would not be straight in an equation that was not in slope-intercept form. So that's what we need to answer there. So that's how we answer the questions for the equations. And finally, we have two tables. Each table has a left and a right side, or an x and a y side. In this case, it's S and A. That's okay. So we're going to look at these two questions, or these two tables, I should say. And we need to decide if they're linear or not. So when you look at a table, you need to understand what the word constant means. The word constant means that on each side, the values need to be increasing at a constant rate, meaning each side needs to have the same increase or decrease each time to be linear. So let's write our template. Boom, boom, and let's see. From 0 and 0 here, 0 goes to 1, 1 goes to 2, 2 goes to 3, 3 goes to 4. That seems like on the left side it's a constant rate of 1, right? Constant rate. We taught rate in the last lesson. So increase by 1 on each side. That's constant. Now look here. From 0, it goes to 1. All right? But from 1, it goes to 4. So did we have the same increase from 1 to 4 as we did from 0 to 1? It doesn't look like it, right? Because from 0 to 1 is plus 1, and then from 1 to 4 is plus 3, and then from 4 to 9 is plus 5. So that's not constant. This table is not increasing at a constant rate. So when we answer a question like that, this example does not represent a linear function because it does not increase at a constant rate. And you would go on to say like S increases by 1, and then A does not increase at the same rate each time. Be as detailed as you can. And finally, look at this table. So from 0 to 1, plus 1, but from 1 to 3 is plus 2, and then we're plus 2. Now you might be thinking, oh, that's not the same. But you also need to look at the y side to decide that. Because if this increase is plus 2, essentially doubling because we have a plus 1 and then a plus 2, right? Instead of adding 1, we added 2. It doubled. This side needs to do the same thing. So if something changes on this side, this needs to represent the same change. From 0 to 1 is 1, and from 1 to 3 is 2. So on the left side, we have for every 1 we increase on x, we increase by 2 on y, right? Plus 1, plus 2. So if plus 1 is plus 2 here, then if I have plus 2 here, I should have plus 4. Is 3 to 7 plus 4? It is. So even though it looks like it changes, if we had the 2 and the 4 and the 6 in the table, you would see that the y will keep its constant rate, and that this table does represent a linear function because it increases at a constant rate. For every one time x increases, y increases by 2, right? So finish the sentences for the other ones and submit your best work, and I'll check it from there. But remember, to be linear, the graph needs to be straight, the equation needs to be in slope-intercept form, and for a table, it needs to be at a constant rate.